I would say the most important thing about factoring in general is relating it to where it comes from, what it is the opposite of. So it's the opposite of expanding. And when we notice a pattern in the expanding, we take advantage of that pattern in order to undo the expanding, which is what we call factoring. Okay? So what do you notice about those three expanding questions and the result that you get? We're looking for a pattern here. So it's all about an observation, something you notice, right or wrong. It doesn't have to be the right thing. Okay. Very good. The result all have a negative sign in the middle. Nice, that's an important one. Yep. What else? Go ahead. Yeah, that's a little bit because of what we started with, so it's not like every question will work that way, but you're exactly right. They all start with x squared. Good. What else? What anything else you see about the result or about the question that you started with as well? Look for patterns. Adam?
All of the numbers that are in brackets are the same in the column.
Right. So 3 and 3, 4 and 4, 5 and 5. Good. What else?
Like 3 times 3 is 9, 4 times 4 is 16, 5 times 25.
Good. Very nice.
They each have one x plus or minus thing with the addition sign and subtraction one.
Okay, good. So it's a 3 and a 3, but one's plus and one's minus. 4 and a 4, one's plus, one's minus. 5 and a 5, one's plus, one's minus. What's another way of writing 5 times 5?
5 squared.
5 squared. So that means these are all what we call perfect squares. What's the big deal with a perfect square? If you take the square root of it, you get a whole number. So somebody tell me a perfect square. I'm going to start with the first one is 1. Does anybody know what the next perfect square number is? 2 isn't a perfect square. 4. And then we saw this one 9. And then 16. And then 25. I'm going to stop there. So if I take the square root of 4, it's going to give me a whole number 2. If I take the square root of 9, it's going to give me a whole number 3. If I take the square root of 16, it's going to give me a whole number 4. If I take the square root of 15, it's going to give me something else, a decimal. A number that you take the square root of, and it gives you a whole number, an integer, is called a perfect square. So you notice these are all perfect squares. 3 squared, 4 squared, 5 squared. Knowing the list of squares can be very helpful for this. So you recognize them, and you don't have to use a calculator to check. So this is like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So what is 6 squared? 30. Close. 30 what? 36. 6 squared. What's 7 squared? Come on, help me out. Get your calculator if you have to. 49. 8 squared. 9 squared. 10 squared is 100. Whoops. 11 squared. Nice. See, you guys know this. This is awesome. 12 squared. And this will be the last one we do. What's 13 squared? Anybody know this one? 169. Very good. And you can keep going, obviously, forever. But if you know every single one of those, that's awesome. That you wouldn't need to know more. And even if you don't quite know all of them, if you know a bunch of them, you'll find that very helpful. So take a look. If you wanted to write down these examples and write down this little note to yourself, you could look it up online later, but it might be helpful. Each term in the result, so we're looking at these now, is a perfect square. The sign between them is subtraction. That's what we're looking for. Because I saw that this pattern gives me that result. This pattern gives me that result. This pattern gives me that result. In fact, let's do one of these and we'll see why. Okay, so again, just watch. X plus 3, x minus 3. How do I expand? X times x and x times negative 3. Right, we do this. So that's x squared minus 3x plus 3x. 3 times negative 3 is negative 9. What's going to happen here? Is this familiar? We take the two middle terms and add them together because they're like terms. But because I had the same numbers with opposite signs, I've got one positive and one negative, and they add to 0. And I'm only left with two terms. There's the pattern. This is why this works. It only works in this case. There's no other situation that you could make up where this pattern would apply. And that's probably the trickiest thing of today, is trying to apply this in places where it doesn't apply. So here's what I want you to write down. Let's try this example factor fully. Example 1a, x squared minus 100. If you're feeling a little bit like you're not following it, don't worry. This is easy. A little bit of practice, you'll nail it. Never forget it. But I would say, if you're not entirely following what I'm saying right now, after we've done a bunch of examples, go back and think about what we just did and see if it clicks, because it will help. So what do you notice about x squared minus 100? Ethan, your hand was halfway up. What were you going to say?
I was going to say that
100 is a perfect square. Exactly. And x squared is a perfect square. That one's not as obvious, but trust me, it is. And what is between them? A minus sign, a negative sign. So this qualifies as a difference of squares, because it's x squared minus a perfect square. Okay? So it qualifies as a perfect square. That means I can write it like this. This is what you need to know. What do I fill in the brackets? It's just like the other stuff that we did, but what do I fill in the brackets that's going to make this all work? Brianna? Very good. Think about when we just expanded that other one. Think about the pattern we saw, and think about how this would work. And factoring is the process of taking some expression like this and breaking it up into multiplication. And that's what we've done. And you might ask, why would we do this? Well, it's not clear right now. We're just learning how to do it. We'll talk about why next week. Okay, let's try another one. So now you see why it can be helpful to know some of the numbers on that list. Because if you don't know if 36 is or isn't a perfect square, you just check it on your calculator, I guess. So go ahead and try this one. Noah, what do you think about this one? How many people put that? See? I told you this was easy. Okay, another one. What's different about this one? Huh? They're switched. Does that matter? No, very good. Because they're still both perfect squares and you're subtracting. But the order that you write your answer does matter. So you have to write it in the same order as the question. Go ahead and try that one. So these ones are tricky because we won't see questions like this as often. And you fall back on the pattern you're used to and you try to do it like the other questions. But does anybody want to try this one? Summer? Awesome. Exactly right. So if that was what your gut was telling you, good. But if you wrote y plus 9, y minus 9, that's a little bit wrong. Because y minus 9 and 9 minus y are not exactly the same thing. Go ahead and try this one. Who's done? Who's done this one? Okay, tell me if this is what you put. Did you put that? Well, I tricked you. That's wrong. I tricked you. And you fell for it. Maybe some of you didn't, but look. What's the same in all of these? They have a minus sign. Listen carefully. Put your pencil down and listen. If this is a plus and this is a minus, you're going to get a minus sign in there. And the middle terms are going to cancel. If I multiply this out, just watch, I get x squared plus 4x plus 4x, both pluses, not minus, plus 16, and those add to 8x, which is not that, so it's wrong. I tricked you and you fell for it. This is not possible. Don't leave it blank, because then that looks like you didn't know what to do. Not possible, not factorable, can't do it. Give me something like that. You're trying to trick me. I'm not falling for this. Whatever you want, something like that, and you get those ones right. It only works when there's a minus sign between them. Only. I can pretty much guarantee you I'm going to try to trick you on a quiz or a test as well to see who's paying attention and who's really thinking about this stuff. Okay? One little mark, not a big deal, but keep that in mind. When it is adding, it's not factorable. You can't do it. I don't know why. The exam's usually pretty straightforward. There's not really tricks on it, but I mean, that's a small one, so I don't know. I wouldn't worry too much about it. If you remember it for the test, you'll remember it. Okay, this one's a little bit trickier. We won't see too many like this either, but we're going to try it today anyway. What do you notice about this question? There's a 9 in front of the x. What do you think about 9? 3. Square root of 9 is 3. It's still a perfect square. So this one still can be done, okay? Because 9 is a perfect square. So try and guess. I'm not tricking you anymore. Try and guess how you would write this one. Brianna, what do you think? Very nice. If you wrote that, give yourself a little pat on the back. That's awesome. Your intuition, your understanding of this algebra is really coming along. Well done. Try this one. Sometimes when we throw 1 into the mix, even though it's like the easiest number to do math with, for some reason it fools us. Remember when we did factoring and 1 was in there, it would sometimes trick us. How do I do this one? Summer? You got it. X times x is x squared, minus x plus x, gone, and 1 times negative 1 is negative 1. So that works out. All right. Here is our practice. It is online, but I'll leave this up here. Try to factor each of those. And then we have a learning goal at the end as well.